It is the summer of 1942, and somewhere beneath the English countryside, a group of engineers are arguing about paper. Not metaphorically, not about paperwork or bureaucratic red tape, though there is certainly plenty of that. They are arguing with genuine professional passion about the material itself, about its grain and its density, about the way it absorbs moisture at altitude, and what that does to its structural integrity under pressure, about whether or not something so thoroughly, defiantly ordinary could be made to kill a man. Outside, Britain is exhausted. 3 years of war have ground the nation down to something lean and improvised. The great workshops of the Midlands are running around the clock. The Atlantic convoys are fighting their way through wolf packs in seas so cold that a man overboard has perhaps 15 minutes before the cold finishes what the sea began. In North Africa, the Eighth Army is locked in a grinding, punishing campaign across terrain that seems designed specifically to break machinery and morale in equal measure. Rationing has reached deep into the domestic fabric of life, the sort of war where every household keeps a careful eye on their sugar allowance and nobody throws anything away. And yet, here, in a converted facility that sits somewhere in the bureaucratic overlap between the Ministry of Supply and the Department of Scientific Research, men with advanced degrees in materials, science, and structural engineering are building weapons out of paper. Compressed paper, reinforced, laminated, precisely engineered paper, but paper nonetheless. The weapon they are working on is called, in the clipped language of wartime procurement, the paper cartridge case. And within 2 years, it will be manufactured by the millions. It will be fired from some of the most powerful artillery pieces in the Allied arsenal. It will be used at Normandy, at the Gothic Line, and in the final push across the Rhine. And when the war is over, most people who fought it will never have known it existed. This is the story of how Britain, facing a crisis of materials it could not solve with metal, solved it instead with something that most people would hesitate to use in the rain. To understand why engineers were reduced to experimenting with paper in the first place, you need to understand the particular hell of wartime logistics. By the middle of 1941, the British war economy was operating under pressures that would have seemed fanciful in peacetime. Brass, the copper-zinc alloy that had been the standard material for artillery cartridge cases since the late 19th century, was becoming critically scarce. The mathematics were stark and unforgiving. A single medium artillery piece might fire hundreds of rounds in a sustained barrage. Each round required a cartridge case. Each cartridge case required a substantial quantity of high-quality brass. Brass required copper. Copper required mining, refining, and shipping from sources that were increasingly contested by submarine warfare and competing Allied demands. The figures involved were extraordinary. A typical 25-pounder field gun cartridge case weighed roughly 1.4 kilograms of brass. In a major offensive, a single battery of 8 guns might fire 3,000 rounds in 24 hours. Scale that across an entire army corps, across multiple theaters of operation, and the copper consumption becomes almost geological in its scope. Britain was quite literally running out of the raw material it needed to keep its guns firing. The obvious solution, steel, had already been explored and found deeply wanting. Steel cartridge cases had been trialed in various forms, and the results were consistently problematic. Unlike brass, which expands uniformly under the pressure of a firing charge and then springs back slightly to allow extraction, steel behaves less cooperatively. Cases jammed, extractors failed. In the heat and dust of North African combat, a jammed case was not merely an inconvenience, it was a gun taken out of action at precisely the moment when it was most needed. The Royal Artillery had very firm views on this, and those views were communicated upward through the command structure with a directness that military bureaucracies generally reserve for genuinely serious matters. Aluminium had also been considered and rejected. The aircraft industry had first claim on aluminium, and the arithmetic of priorities was straightforward. A Spitfire was worth considerably more to the war effort than a cartridge case, and there were thousands upon thousands of cartridge cases required every single day, which brought the engineers with a certain inevitability to paper. The facility primarily associated with this work was operating under the auspices of the Woolwich Arsenal's Research Division, though the precise organizational structure shifted several times during the war as responsibilities were redistributed and departments amalgamated in the way that wartime bureaucracies tend to do. What remained constant was the team of engineers and materials scientists who had become, through sheer necessity, the world's leading experts on the ballistic properties of compressed cellulose. The concept they were developing was not, in the strictest sense, entirely new. Paper cartridge cases had existed in various primitive forms since the very earliest days of gunpowder weapons. The paper cartridge, combining powder and ball in a single package, was a standard infantry item as far back as the 17th century. But those were paper in the most literal sense, a thin wrapping around loose powder, torn open with the teeth before use. What the Woolwich team was attempting was categorically different. They were trying to engineer a self-contained cartridge case, a structural component capable of withstanding the enormous pressures generated by a firing charge, sealing the breech of a gun against the rearward escape of propellant gases, and then being extracted cleanly from the chamber after firing. In brass, these properties were achieved by the material's natural characteristics. In paper, they had to be engineered from scratch. The solution involved multiple layers of paper, wound under tension and bonded with carefully formulated adhesives into a composite structure that bore very little resemblance to anything you might find in a stationery cupboard. The paper itself was not ordinary paper. It was manufactured to specific tolerances from selected fibers, with consistent density and controlled moisture content. It was then wound in spiraling layers, each at a calculated angle to the previous one, building up a tube whose wall thickness and structural characteristics were precisely specified. The resulting material behaved under compression more like a form of engineered wood than like anything most people would recognize as paper. It had genuine structural rigidity. It could be machined, drilled, and formed into precise shapes. And critically, when subjected to the pressures of a firing charge, pressures measured in thousands of atmospheres, applied over fractions of a millisecond, it responded in ways that the engineers could predict and control. The base of the cartridge, where pressures were highest and dimensional accuracy most critical, was reinforced with a metal head, typically brass or steel, that handled the interface with the gun's firing mechanism. But the body of the case, the large cylindrical section that would previously have been formed from a single piece of drawn brass, was now composed entirely of this engineered paper composite. The manufacturing process was carried out at multiple facilities across Britain, with the paper winding operations eventually dispersed to smaller workshops that had been converted from peacetime uses. Exact production figures remain, in some instances, classified or simply unrecorded. The wartime paperwork, with a certain irony, was not always comprehensively preserved, but estimates from post-war assessments suggest that millions of paper cartridge cases were manufactured and issued during the final years of the war. The rounds armed with paper cartridge cases entered service with the Royal Artillery in the North African campaign, though the precise date of first operational use is not definitively established in available records. What is clear from subsequent reports is that the performance, under the demanding conditions of desert warfare, was considered acceptable, which, in the understated vocabulary of British military assessment, meant that the guns kept firing and the cases kept extracting, and nobody was complaining loudly enough to stop the program. The conditions in North Africa were, it should be said, about as hostile to paper-based materials as any environment the engineers might have designed specifically to destroy their work. Heat that reached well beyond 40 degrees Celsius. Fine, penetrating dust that worked its way into every mechanism. Humidity that swung between parching aridity and the occasional moisture-laden maritime air from the Mediterranean. Paper, under these conditions, had no business performing reliably, and yet, by all accounts that survive, it did. Part of the reason lay in the careful engineering of the moisture barriers built into the manufacturing process. The composite structure was sealed against casual moisture ingress, and the rounds were packaged and stored in ways that maintained their integrity until the moment of use. Once a round was loaded into a chamber and fired, the paper case's properties were no longer relevant. The gases had expanded, the projectile had left the barrel, and what remained was a spent case to be extracted and discarded. In Italy, where the fighting moved after the North African campaign concluded, the paper cases were in wider use. The Gothic Line battles of 1944, the grinding advance through terrain that used every hill and every river as a defensive obstacle, consumed artillery ammunition at rates that made the earlier supply concerns seem almost quaint. The paper cases helped keep the guns supplied at a moment when brass would have been simply unavailable in the quantities required. There are accounts, though accounts of this kind should always be treated with appropriate caution as they pass through multiple filters before reaching the historical record, of Italian and German ordnance officers examining captured British ammunition and expressing considerable surprise at what they found inside the cartridge cases. The idea that the British were making artillery ammunition out of paper struck more than one observer as either a sign of desperate shortages or a sign of engineering ingenuity that bordered on the perverse. They were right on both counts. If you are finding this interesting, a quick subscribe helps more than you know. It genuinely keeps this channel going. The Germans, it should be noted, were not entirely unfamiliar with the concept. German ammunition development during the Second World War explored a number of alternative cartridge case materials driven by the same pressures of copper and brass shortages that were affecting every major belligerent. Their principal alternative was the steel cartridge case, which they pursued with characteristic engineering thoroughness and which worked considerably better in German guns, which had been designed with tighter tolerances and were better maintained, on average, than in British and Allied weapons. They also explored pressed steel cases with lacquer coatings to reduce friction and various combinations of steel and other materials. What the Germans did not pursue seriously, at least not in operational quantities, was paper. This was not because the concept was unknown to them. German technical intelligence was generally excellent, and the British paper cartridge case program did not remain entirely invisible to German analysts. The decision appears to have been a matter of prioritization. The German arms industry had committed its alternative material resources to steel, and the industrial infrastructure required to pivot to paper composite manufacturing at scale was not readily available. The Americans, meanwhile, were working along parallel but distinct lines. American ammunition manufacture benefited from the enormous productive capacity of United States industry and the relative abundance of raw materials available to a nation that, for much of the war, was not being bombed or blockaded. American artillery rounds were predominantly manufactured with conventional brass or steel cases, and the paper composite approach was not adopted at scale. The British solution was, in this sense, a specifically British problem answered with a specifically British kind of improvisation. The sort of lateral thinking that tends to emerge when the straightforward answer is simply not available. It is worth noting that the paper composite case did have genuine engineering advantages beyond simple material substitution. The cases were lighter than their brass equivalents by a meaningful margin, which had logistical implications for transport and handling. They did not require the same reclamation and recycling infrastructure as brass. A significant consideration, given that brass cases had traditionally been collected, shipped back from the front, and reprocessed, a supply chain that was under constant pressure from the realities of active combat. And in certain respects, the thermal behavior of the paper case during firing was actually preferable to metal alternatives. The legacy of the paper cartridge case is complicated by the fact that it was, in some important respects, a secret that was kept too successfully. Wartime security requirements meant that the program received essentially no public attention during the conflict. After the war, the triumphant narrative of Allied victory was written primarily around technologies that were more dramatic and more visible. Radar, the bouncing bomb, the Mulberry Harbors, the Colossus computer. The humble paper cartridge case, which had helped keep the guns firing at a series of critical moments, received essentially none of the attention it arguably deserved. The technical lessons of the program were not entirely lost. The engineering principles developed during the wartime research, the understanding of how paper composite materials could be engineered to precise structural specifications, the manufacturing techniques for consistent wound paper tubes, the adhesive formulations that maintained integrity under extreme conditions, fed into post-war materials science in ways that are difficult to trace precisely, but almost certainly significant. The broader field of engineered composite materials, which would become enormously important in the second half of the 20th century, owes something, if an unquantifiable something, to the work done by engineers who were trying to make cartridge cases out of paper. Surviving examples of wartime paper cartridge cases can be found in a small number of specialist collections, primarily at the Royal Artillery Museum at Larkhill in Wiltshire, and in the collections of the Royal Armouries. They are, inevitably, not the most visually dramatic exhibits. A paper cartridge case looks, in cross-section, like a moderately interesting piece of industrial engineering. The significance requires explanation. The drama is in the context, the psychological impact of the discovery, not on enemy forces, who were largely unaware of it, but on the historians and engineers who have studied it since, is perhaps the most revealing aspect of the whole program. It forces a reconsideration of assumptions about what weapons are made of, about what materials can be trusted under extreme conditions, and about the relationship between scarcity and innovation. That is one of the consistent themes of the British war effort. Return then to that converted facility in the English countryside, to the engineers arguing about paper. They were right to argue. The stakes were not trivial. The guns of the Royal Artillery were among the most decisive weapons of the British war effort. Field commanders on every front, from North Africa to Northwest Europe, consistently identified artillery support as the single most important factor in ground combat effectiveness. Anything that threatened the supply of ammunition to those guns threatened the capacity to fight. Anything that solved that supply problem, however strange the solution might appear, was worth every argument about grain direction and moisture resistance and adhesive formulations. What those engineers produced, over years of incremental development and quiet, unglamorous testing, was a weapon component that worked. That met the specification, that kept the guns firing when the brass was not available, and the steel was too problematic, and the alternatives had all been exhausted. It did not look impressive. It did not feature in newsreel footage or generate newspaper headlines. It was not the sort of innovation that won its inventors decorations or public recognition. It was simply, stubbornly effective. There is something characteristically British about this. The willingness to take a material that everyone knows is inadequate for the task and spend years of careful, systematic engineering effort, turning it into something that works anyway, not with a flash of genius, not with a single breakthrough moment, but with iteration and stubbornness, and the particular kind of quiet competence that tends not to photograph well. By the end of the war, millions of rounds had been fired using cartridge cases that were, in their essential structure, made from paper. Guns that might otherwise have fallen silent kept firing. Offensives that might otherwise have stalled for want of ammunition went forward. Battles that turned on the weight of artillery fire. And in the Second World War, most battles turned on the weight of artillery fire, were won in part because someone, somewhere, had been willing to have a very serious argument about paper. The weapon that seemed impossible became the weapon that was everywhere, and because it did its job invisibly, in the unremarked background of artillery operations, it remained exactly as unnoticed as its makers would have wished. Paper, compressed, engineered, precisely wound paper, and the war, in some small but real measure, turned on it.